Okay, so as promised, here's the video for section 6.4, which is about calculating normal probabilities. Some of this is going to be very similar to what we've done before. So let's say that we've got heights of students are normally distributed, and there's a mean of 68 inches, a standard deviation of 4. So if we look at the table down here, or the graph down here, we see that the mean is 68, and then each one of these are an increment of 1 standard deviation. All right, so a couple of questions then. What percent of heights are less than 64 inches? So if we jump over here to where 64 is and we think about the empirical rule says that 68% will be between 64 and 72. So that means that there's going to be 32% left over. Half of that will be in the left tail. And so that probability is 16%. All right, then what about greater than 76? So 76 corresponds to 2 standard deviations above the mean. The empirical rule says that between 60 and 76 is going to be 95%, which means that there's 5% left over, which means that half of that 5% is going to be in this upper tail, so that probability is about 2.5%. Okay, what percent of heights are between 60 and 72? So 60 represents 2 standard deviations below the mean, 72 is 1 standard deviation above the mean. We could find the probability of being in this tail is 2.5%. The probability of being in this tail is 16%. So if you add those together, you're going to get 2.5 and 16 is 18.5%. But we want what's left over, so 100 minus 18.5% gives us about 81.5%. Okay, so for these 3 problems, then, this is nothing different than what we did before. We're just looking at the empirical rule. Now, suppose we want to know what percent of heights are less than 73. So the problem with this is now that 73 is not an integer multiple of standard deviations. All right, now there are several ways we could do this using some technology, and I want to show you a couple of things first. So first thing is, let me show you a file that I made up here, which is in GeoGebra, which is a free software package that anybody can get. Now, I set this up. It took me about an hour this morning to get all this stuff ready, but here's what we can do. We can say, well, what happens if we slide this over to 73 inches? All right, and so the program is set up so it's going to give me the area of this tan region, and it says that that probability is about 89.4%. Right, now, what it did is it calculated a z-score, and it calculates a z-score of 1.25. So it's telling me that 73 is 1.25 standard deviations above the mean. Remember, 72 is 1 standard deviation above, 76 is 2. So this is a fourth of the way between 72 and 76. So we calculate this by taking the value of x and subtracting the mean. Okay, so the numerator tells me how many inches in this case I am above the mean, which is going to give me 5. And then divide by a standard deviation of 4, and that gives me 1.25 standard deviations. This is a formula that we're going to use quite often in this section. All right, and then how we calculated this probability, basically the program is doing calculus to find this probability. We're not going to worry too much about how it's calculated at this point, but we do want to be able to come up with this answer of 89.44%. All right, so let's go back then and pick up this PowerPoint again and go over that question. So we said that answer, all right, that shouldn't say 10%, that's a typo. Okay, that should end up being about the answer that was on that previous page, which was about 89.44%. Okay, so moving forward then. All right, so let's say we have this problem again. We want to calculate the percent of heights that are less than 73 inches. All right, so basically we're looking for the area of that gray region. All right, and we just said that the z-score there is 1.25 and the answer is 89.44%. All right, but what I'd like to be able to do is not rely on this software so much and rely on some other sources. All right, so I'm going to refer back to the table. All right, and this table is going to give you z-scores and then also gives you the proportions that are within a region. All right, so when we calculate this problem, we're looking at a z distribution. right? And a z-distribution is just number of standard deviations above or below the mean. All right, so the z-distribution is going to be centered at 0, and the question in here now is, if I go out here to z equals 1.25 and I want to calculate this probability to the left, all right, I've got to do that using some kind of method other than the program that I've given you. All right, so here's the way that that table works. So for this table, we're going to go to, whoops, we're going to go to the table that includes the positive z-scores, right? And so the picture at the top of the page looks very much like what I just drew on my paper. I want to find the probability of being to the left of 1.25. So here's the way it works. Okay, I got to find a z-score of 1.25, and here I find the first two digits of that 1.25. The third digit of 1.25 is up here, and then I look at the intersection of this row and this column, and I come up with an answer of 89.44. All right, so this probability of being in this tail is 0.8944. Okay, so I'd like to work through a few problems like this using the table. So let's jump back to our PowerPoint, and let's do some standard normal calculations. So we want to find out the probability that z is less than -1. All right, I'm going to tell you that we already know the answer to this one because of the empirical rule. It should be about 16%. All right, but if I want to use the table to do that, I'm going to be looking at another standard normal distribution centered at 0. I want to find where z is equal to -1, and the question said find the probability that z is less than -1. All right, so we go to the part of the table where z takes on negative values, which is going to be on the first page of this table. We find -1.0, and then the third digit is 0, and so the intersection of these gives me 15.87. Okay, so it tells me that the probability of being in this tail is 0.1587. All right, now the empirical rule says that this is 16%. Okay, and the empirical rule, again, is just an approximation. Okay, so let's go back to the PowerPoint then. The answer to this one is 15.86. Okay, what if I wanted to know the probability that z is less than 0.75? All right, so again, I'm going to be looking at a standard normal curve centered at 0 with a standard deviation of 1. The question was, what's the probability that z is, I'm going to go back to the problem again, z is less than 0.75. So we find this is 0, this is 0.75. We're looking for the area to the left. So in the standard normal table, I'm going to find in the positive side of this table 0.75. So I go to 0.7. The second digit after the decimal is 0.05, and I find that that answer is 77.34%. All right, so 0.7734 is that region. Okay, let's go on to another one. So what if I want to know what's the probability that z is bigger than 1.23? Right, I'm going to pause here and let you guys look this one up, see if you can come up with an answer. What's the probability that z is bigger than 1.23? I'll give you a minute. Okay, so what we're looking for in that table is what is the probability of being to the right? Okay, so we're going to look up in the table 1.23. So I go to 1.203 and I find a probability of 89.07. All right, so 0.8907. All right, but that is the probability of being on this side of 1.23. So to find the answer over here, we've got to take 100% and minus 0.8907. All right, so you're going to get an answer of about 11% or so. All right, so go back to the PowerPoint, and the answer is 10.93. Okay, about 11%. All right, what about the probability that z is between -1 and 1? All right, so now we're looking for what is the area in between -1 to 1. All right, the empirical rule applies here, and the empirical rule says that this is going to be about 68%. All right, but I want to use the table in order to come up with the same answer. All right, so I'm going to have to calculate the probability of being to the left of 1. All right, so the probability of being to the left of 1, I look up in the table, and I find that in the table to the left of 1 is, go to 1.00, and I find that that's 8413. All right, then I want to know what is the probability of being to the left of -1. So I go over to the other half of the table, I go down to -1, and I find that this probability is about 15.87. Okay, so that's the area being in this tail. So in order to find the area in between, I'm going to subtract these two, and you're going to get that that answer is about 68%. Okay, so when you subtract, let's see, I keep going to jump back and forth here. All right, so the first answer was 8413 is everything to the left of 1. 1587 is everything to the left of -1. To get the area in between, I subtract those two, and I'm going to get about 68%. All right, so let's go back here, and calculator says about 68%. Okay, I'm going to let you do this one. Find the probability that z is between -2 and 2. All right, we should know what our answer is going to be approximately equal to by the empirical rule. The empirical rule says about 95%. All right, we want to calculate the probability using the table. Okay, so I'm looking for the area in between. So if I want to know what's the probability that z is less than 2, I can find that in the table. So I go to 2 on the positive side of the table, and I go to 2.0, and I find that that's 97.72. All right, so 0.9772. And then I also want to calculate the probability that z is less than -2. All right, so that's going to be everything that's in this tail. And so the probability of being in that tail, we go over to the other half of the table again. We go down to -2, and I find that that proportion is 0.0228. All right, and then we're going to subtract those, and we're going to get the answer. All right, so the answer comes up to be about 95%. Okay, next one. What's the probability that z is bigger than 3? All right, so to find this one, what you could do is go to the table, find out what's the probability that z is less than 3. All right, so the probability that z is less than 3 is this number. So the probability that z is bigger than 3 is the complement of that. So 1 minus 0.9987 is going to give me about 0.0013. All right, now the empirical rule says that that answer is going to be 0.0015. Right? We're not going to sweat the fourth decimal place. All right, now another way that you could do this is you could say, well, the probability of being bigger than 3 using the symmetry of the table is that we could go over to probability that z is less than -3. And probability that z is less than -3 is the complement of z is bigger than 3. So you can use the symmetry of the table to find right tail probabilities as well. Right? Several textbooks only have the positive side of this table included, and they just expect you to use the symmetry of the table to come up with answers like that. Okay, so using the table is fairly simple, just looking up z-scores and finding the area to the left or to the right. Right now, this one says, what is the value of z that's going to cut off the bottom 90%? All right, so this one is a little bit different kind of a question. So let me draw you a picture of what this is asking you to do. All right, it's saying that in your z distribution, there is a place out here where z is equal to some number, and we get 0.9 is the area to the left. All right, so one way that you could do this is you could go to the body of the table, and we're looking for where is the area equal to 90%. So I'm looking in the body of the table, I'm looking for a number that's pretty close to 90%, and the closest I can find to 90% is this one right here. Okay, 89.997. All right, so if we work outward, that's going to correspond to a z-score of, we're in the row that is 1.2 and the column that's 0.08. So that's going to correspond to 1.28. Right, so if we go back here, this number is 1.28 is the number that cuts off the bottom 90% from the top 10%. Okay? All right, then for the next one, find the IQR for the standard normal distribution. Okay, so we want to find out what values are going to cut out the middle 50%. All right, so to find, let's say Q3, Q3 is going to give me the value for which 75% is to the left. All right, so if we go to the table, and we're looking for 75 this time, 75%. So we're looking around until we find something pretty close to 75%, and it looks like 75% is closest to, it looks like it's in between these two values. We're going to say it's that number. Okay? I guess this number is closer. All right, so we'll say that that number is about 0.67. Okay, so 0.67 is going to be the 75th percentile. Right, so this is 0.67. And then we want to find out what's Q1, and Q1 is the value that's going to cut off the bottom 25%. Right, so if we go back to the table, and we find the value that's going to cut off the bottom 25%, so I'm looking for 25% in the table, and I'm going to find 25% corresponds to, I think the closest number I'm going to find is, see, 25% is right about here. Okay, and that corresponds to negative 0.67. All right, so the bottom quartile is negative 0.67, the top is this. So the IQR, remember, is Q3 minus Q1. So we're going to get 0.67 minus negative 0.67, and that's going to give me an answer of about 1.34. So 1.34 is the IQR for this distribution. Okay, 1.34, 1.35. Okay, so what I'd like to do next is take a look at another method for coming up with these answers. All right, so let me go back to this page, and I want to show you how we can calculate these another way. All right, so let me run this again. All right, so we want to know what's the probability that z is less than -1. We already said that the answer to that was about 16%. Okay, now there is a built-in program on your calculators, and it's called the normal CDF. All right, and I want to do a couple things here. One is, if you have a newer model of the TI-84, you're going to be using normal CDF. Okay, normal just means it's a normal distribution. This part means it's a cumulative density function. All right, essentially, it's just area underneath the curve. All right, so the way that this is going to work is the calculator is going to ask me to give a lower value and an upper value. Okay, so if I wanted to know what is the proportion of z-scores that are less than 1. Okay, so on the calculator, I'm going to put in normal CDF And the lower bound is going to be some number, and the upper bound is going to be 1. Because I'm looking for what is the probability that z is less than 1. I'm looking for this area over here. All right, now you might say that there is no lower bound because this is going to keep going forever. However, this distribution ends up getting really close to the horizontal axis, and after a while there's basically 0 area underneath the curve over there. So if I put in a relatively large number like -100, that's going to act like -infinity. Okay, so where are these buttons on the calculator? So if you go to your TI-84 graphing calculator, right, and I've got the newer model here on the screen, the commands are under second and then vars. Okay, that first choice there, notice it says normal, but it says PDF. The normal PDF is just a function that's going to sketch the normal curve. It doesn't do anything in terms of area underneath the curve. In fact, I can't think of a place where we might use that for this course. Okay, so I'm going to pick choice number 2, right? And then it's going to ask me, what's the lower bound? So just put in there -11 or -100. Okay, and then I want to learn the upper bound. Upper bound is 1. Okay, now we're talking about this, the normal distribution. The z distribution has a mean of 0 and a standard deviation of 1. All right, and then all we're going to do is paste that into our home screen and then hit enter, and it tells me that that answer is about 0.8413. Okay, so the probability of being less than 1 is 0.8, what was it again? 8413. Okay, which is about 84%, which is what the empirical rule says it should be too, about 84%. Okay, so let's see if we can do a few of these on the calculator. Okay, so I guess it said less than -1. Sorry, I did the wrong one there. All right, how about less than 0.75? So to find the probability that x is or z is less than 0.75, we go to the calculator, and let me write this down first. The probability of getting a z-score that's less than 0.75. All right, I think it's good practice for you guys to draw the normal curve, label 0.75, and we're looking for the area to the left. All right, so z is less than 0.75, area to the left. And we want to calculate this using the calculator. All right, so on the calculator, this is going to be a normal CDF. All right, and then the lower value we can put in -100, and the upper value we could put in 0.75. Okay, so go to the calculator. We choose again second vars, choice number 2. The lower bound we can still put in there at -100. The upper bound, now I'm going to put in 0.75. And then I'm going to paste that in the home screen, hit enter, and it tells me that that answer is about 0.7734. All right, so 0.7734 is this area. Okay, the next one then. The probability that z is bigger than 1.23. All right, now this is the nice thing about the calculator is that if I'm looking at the probability that z is bigger than 1.23, and I want to know what's its right tail probability, okay, we can put in normal CDF. Now the lower bound is 1.23, and the upper bound is just a big number, okay, and 100 is generally big enough there. All right, so if we go back to the calculator again, and we say second vars, choice number 2, the lower bound now is 1.25, or I'm sorry, 1.23, and the upper value now is going to be positive 100. Okay, and then if you paste it, and then hit enter, it tells me that that answer is about 0.1093. Okay, So we've got several other problems here that are very similar to that. For this one, the probability that z is between -1 and 1. Remember on the calculator or on the table we had to look up two values and then subtract them. All right, so now if I do this on the calculator and just say what is the area between -1 and 1, right, I can just say the lower bound is -1 and the upper bound is +1. And hit enter. Oops. I think I know what I did wrong. Yeah, it doesn't like that negative. I hit this subtraction instead of the negative, and then hit enter. All right, so it tells me about 68%, okay, which is consistent with what we've done lately. Okay, so you don't have to subtract then if you're doing those. All right, so then the next one, what's the probability that z is between -2 and 2? You do exactly the same thing, you just plug in -2 and +2. Right now, for those of you that don't have the Stat Wizard on your calculator, let me show you that if I turn this off, and you're doing the same sort of thing, all right, so let me shut that off, and then if I do second bars and pick number 2, all right, on the home screen it just gives me this, and what I need to know is what is the lower bound, what's the upper bound, so I'm just going to put in -2, and then comma is right above the 7, and then a +2 and close the parenthesis, and the calculator will give me the probability that z is between -2 and +2. It's about 95%. Okay, so that makes it pretty easy with the calculator. All right, probability that z is bigger than 3 is going to be very much like the third problem that we did there. All right, but what about a question like this one? We want to find out what's the 90th percentile. All right, so we got to work backwards from what we did for finding all these probabilities. Right? And a way that I can do this is I can go to the calculator, and there's a nice command here also. You go to second bars. We're doing kind of the inverse of calculating a normal calculation. So if you go down to choice number 3 and say inverse normal, okay, those of you that have the Stat Wizard turned on, it's asking you for an area, and we want to know what is the area to the left is 0.9. All right, and so this is really all the calculator needs to know is we're trying to find out what's the value that cuts off the bottom 90% from the top 10%, and it tells me that that number is 1.28. Okay, and that's the same number that we looked up in the table. Okay, for the next problem, if I want to know what's the IQR, all right, remember the IQR is going to be the 25th percentile and the 75th percentile and the difference between them. So if I go back to the calculator and I want to find out what is the 75th percentile, I can do that almost the same way I did this one. Go down to the inverse normal, but now we want to put in 0.75 and close it, and it tells me about 0.67. All right, and then if I do 0.25, change this to 25%. Everything locked up. And my calculator's locked up. All right, bear with me. I'm going to quit this. Okay, and then I'll start it up again. Okay, so to find the 25th percentile, just put in 0.25 for the area. Okay, so now I want to go back to my PowerPoint, and I want to calculate a few other calculations. So suppose that we're given IQ scores are normally distributed with a mean of 100 and standard deviation of 16. And now the question is, what percent of what percent of IQ scores are going to be less than 108? All right, so here's the process that we need to look at. So we're looking at what's the probability that an IQ score is less than 108. And we're told that the mean is 100 and the standard deviation is 16. All right, so to find the probability that x is less than 108, I first of all got to think about, on my distribution of IQ scores, the mean is 100 and the standard deviation is 16. So let me just write sigma equals 16. So 116 would be here. This would correspond to a z-score of 1. So 108 ends up being halfway in between those two, and so that probability, or that 108, is there. Okay, what I want to calculate then is a z-score for 108. And a z-score for 108 is we take 108 minus 100, so we're 8 units above the mean, and then if we divide that by the standard deviation, I get 0.5. Okay, so 108 is 1/2 of a standard deviation above the mean. So to find the probability of getting an IQ score that is less than 108 is the same as the probability of getting a z-score that's less than 0.5. All right, so I'm going to go to the calculator then and find the answer to this one. So second vars, number 2, normal CDF, and I want to go from negative infinity, all right, so I'm just going to put it negative 100, to 0.5. Right, we should end up with that probability is about 69%. Okay, so the steps on this is, I'd like to have you guys calculate a z-score first, convert it into a z-score, and then I'd like you to calculate that probability using the calculator probably. Okay, or you could also look this up in the table. So if I'm looking this up in the table, I'm going to go here. I'm looking for what's the probability that z is less than 0.5. So less than 0.5, I got to go over to the positive part of the table. I'm going to go to 0.50, and I find that that answer is 6915, okay, which I think is the same answer that we got on the calculator, 6915. Okay, next problem. What percent of scores are greater than 120? Okay, so for this one, same kind of problem, but now we're looking for what proportion are bigger than 120. So on your IQ scale, 100 is the center, 120 is over here, and we're looking for what's the probability of being bigger than 120. All right, so I'm going to calculate the z-score for 120. So we take 120 minus 100 and then divide by 16. All right, so I'm going to get 20 over 16. 20 over 16 is the same thing as, what, 10 over 8, which is, 10 over 8 would be 1.2. I think that's right. 10 over 8, which is the same as 5 over 4. 5/4 would be, no, 1.25. Okay, so we want to find what's the probability that z is bigger than 1.25. So we go to the calculator and we say normal CDF. The lower bound is 1.25. The upper bound is a big number. Okay. All right, so again, normal CDF, choice number 2, lower bound 1.25, upper bound a big number, okay, and then paste that, and it says about 10%. Okay. Now, I'm not naive enough to know that you guys haven't been looking at the stuff that's asked for you there. So let's go back to the normal CDF again. All right, and I want to show you one thing that you can do here. So if we go back to second vars, number 2. Okay, the calculator is smart enough that we don't have to work through these z-scores. Right, so if I say the lower bound is 120, right now I've got to use a big number for the upper bound. 100 isn't going to be big enough now. I got to put in, something unusually large for an IQ score. Right? There's nobody that has an IQ that's maybe above like 200 or so. All right, and then if I tell it what the mean and the standard deviation is, the mean was 100, and the standard deviation was 16. Right, and then if I paste that and hit enter, it gives me the same answer. All right, so those of you that have an older model of the calculator, or you don't have the stat wizard turned on, all right, so let me just shut this off first, and then if you hit second vars and you choose normal CDF, it's going to ask you for 4 things. The first thing is the lower bound. Okay, the lower bound was 120. And it's going to ask you for an upper bound, something big. And then it's going to ask you for the mean. And it's going to ask you for the standard deviation. Right. And then when you hit enter, it'll give you the same answer. Okay, so if you don't have the one of the newer calculators, you just have to remember lower, upper, mean, standard deviation is the parameters that come after that. Okay, so let's go back to the PowerPoint then. We said that this answer is about 10.57. Okay, so if I want to know what percent of the scores are between 90 and 115, all right, so I think that I probably convinced most of you to use the calculator most often, so let's go back to the calculator. The problem said, what's the probability of being between 90 and 115? So I'm going to go to second bars again. Number 2, lower bound is 90. Upper bound is 115. The mean is 100. Standard deviation is 16. And my calculator says that that answer is about 56%. Okay. Another question, what score do you need in order to be at the 90th percentile? All right, so let me show you this one. If you don't use the full features of the calculator. So here we're looking for what's the 90th percentile. All right, so if you go out here on the Z distribution and you want to know what is the value out here that's going to cut off this 90 percentile. Okay, now we saw earlier that the 90th percentile was 1.28, looking it up in the table. All right, now if you go to the calculator and you say second bars and you say inverse normal, number 3. Okay, and then we're looking for the 90th percentile, so if I put in 0.9 and then close this, it's going to tell me that that is 1.28. Okay, now 1.28 is not an IQ score. This is a Z-score. This is 1.28 standard deviations above the mean. So if I want to know what score that is, now I've got to take 1.28 is my Z-score is equal to whatever value is going to be there minus the mean divided by the standard deviation, which is 16, and then I solve this value for X. All right, and I think that the answer for X is going to be somewhere around like 120 or so. Okay, so let's go back to the PowerPoint. The answer is, yeah, about 120.5. All right, now on the calculator also, if I know that I can put in those numbers, let's say I've got the stat wizard turned off still, but if I go to second bars and I do inverse normal is number 3, and I tell it I want 90th percentile, but if I know what the mean is, 100, and I know the standard deviation is 16, the calculator will do this for me without having to convert it into a Z-score first. Okay, so that's kind of a nice feature. Those of you that have the stat wizard turned on, it's going to prompt you for the mean and the standard deviation, so take advantage of that. Okay, so let's go back to here again, and let's find the IQR of the distribution of IQ scores. All right, so this is going to be a problem very much like number 4, except now we're going to be looking for the 25th percentile and the 75th percentile, and then subtract them. All right, so let me give you a minute to find those. Okay, so you should end up with the first quartile is about 89.2, the third quartile is 110.8, and then the IQR ends up being about 21.6. Okay, so that problem is going to be very similar to number 4. Okay, let's see, moving on. Suppose that you got a soda machine that dispenses soda, and it doesn't always give you the same amount of soda every time. It has a mean of 10 ounces and a standard deviation of 0.05 ounces. So what percent of the cups contain less than 9.9? All right, I'm going to have you calculate this one on your own. All right, so if you calculate a z-score on 9.9, 9.9 is -2 for a z-score. And then we want to know what's the proportion that are less than that number. And you should find that by the empirical rule, it's 2.5%. Right, by the calculator, it's going to be 2.28%. Okay, what percent of the cups contain more than 9.97? All right, we've got to pay attention to the more than, and then this value of 9.97. All right, so punch this one in the calculator, see if your answer is consistent with mine. All right, so the probability of being above 9.97, the command is going to be normal CDF. The lower bound is 9.97. The upper bound is just a number that's really, really large compared to the values that are in this distribution. And then the mean is 10 and the standard deviation is 0.05, and you should end up with about 72%. Okay, you're welcome to just pause this video so I don't have to stop, and just pause it, do the calculation, and then check the answer. All right, so what percent of the cups are between 10.03 and 10.08? All right, so again, calculate this one on your calculator. Pause the video until you're ready to see the answer. And the answer is about 21.95%. Okay, cups can hold 10.15 ounces. What percent of the cups will overflow? All right, so we're looking for what's the proportion that are above 10.15. If you think about what a z-score is for 10.15, that's going to be a z-score of 3. The probability of getting a z-score bigger than 3 by the empirical rule is about 0.0015. All right, I think your calculator is going to tell you 0.0013. Right, again, we're not going to sweat the fourth decimal place. Okay, and then this one's just asking for what is the IQR? What's the first quartile? What's the third quartile? All right, so this one's going to be like the one that we did before. You're going to put in inverse normal, 0.75, and if you follow that with the mean and the standard deviation, you should get that the third quartile is 10.034, and the first quartile is 9.966. Okay, last situation. Suppose we've got heights of girls and boys. The girls' heights are normally distributed with a mean of 64 and a standard deviation of 4, and the heights of boys are also normal with a mean of 68 and a standard deviation of 3. Okay, find the probability that a randomly selected girl is more than 67 inches tall. All right, so we're selecting only from the population of girls, so what's the probability of getting 67 or more when the mean is 64 and standard deviation is 4? All right, so the command on the calculator would be normal CDF, 67, comma, a really large number like 100 or 1,000, and the mean is 64 and standard deviation is 4. You should get about 22.66 as your answer. All right, now for this last one, which is more likely to select a girl who's taller than 67 or a boy who's shorter than 67? And what I'd like to look at on this one is seeing if we can do this without actually calculating the probabilities. All right, so let's think about which is going to be more likely, a tall girl or a short boy. All right, so if you look at the distributions of girls and boys, so for the girls, they had a mean of 64 and a standard deviation that was, I forgot now, 64 and 4. Okay, so sigma equals 4. And then for the boys, they had a mean of 68 and a standard deviation of 3. All right, so a tall girl is going to be out here, 67 and above, and a short boy is going to be here, 67 or below. All right, so we want to know which one of these tail probabilities is larger. All right, so if you think about what's the z-score for a 67, the z-score for a 67 is 67 minus 64 divided by 4. That's going to give me 3/4 or 0.75. And then for a short boy, we're going to get 67 minus 68 divided by 3. and that gives me negative 1/3 or 0.33 repeating. Okay, so this value of 67 is 1/3 of a standard deviation below the mean. This value of 67 is 0.75 standard deviations above the mean. All right, you're going to find that this tail probability is smaller than this one, so we're more likely to get a boy that is shorter than 67 than a girl that's taller than 67. All right, and if you actually calculate those probabilities, those calculations are consistent with what we just said. Okay, so I'm going to send out an email here. I'm going to send out what assignments I want you to do, and so look for in D2L. I'm going to put a copy of the table. I'm going to either put this video there, or I'm going to put a link to it, and then also your homework assignment will be included in there someplace. All right. Thanks a lot. Have a great Thanksgiving weekend, and I will see you all on Monday.